All right, good afternoon, everybody. So just to disappoint everyone off the bat, we're not going to have a drop-down, drag-out fight of why is concrete better than asphalt. So this is a kind of difficult topic to talk about, and so when me and Robert kind of sat down to figure out what exactly we were going to say, we wanted to try to avoid this issue of, okay, who's better, concrete or asphalt? So we decided to kind of tackle it from a different point of view, and we'll get into that in a little bit. So, and the other fact is Robert has a little more reach on me, so I think he'll probably take me out pretty soon. So, all right, so with that, I guess we're just going to kind of tag team through this presentation. And you can save all questions for Robert at the end.
Let's just I wanted to kind of start off and just to show you how difficult this particular topic is. And we were just talking about trying to compare pricing between asphalt and concrete. And I said, this is the perfect example of why that it's just hard to, you can't really compare apples to apples. It's apples to oranges is what we call it. And so if you look at CRCP and dense graded hot mix, we took the latest 3-month statewide average bid price. And of course, if you put it into concrete terms, it's about $42.59 a square yard. You take that average for dense graded hot mixes, and that's all the hot mixes. That's about a little over $76 a ton. So we said, well, what if we tried to convert? Well, they're all laid at different thicknesses. And so we said, well, let's try to normalize that data a little bit just to see what it looks like, and maybe put the concrete into a price per ton. And then so if you look at all the concrete and you go and you normalize the data, it's about, that square yard's about for 11 inches of concrete. So the price right now is about $68, $69 a ton. So Andy, you won that one if we're looking at tonnage price. But seeing as how our average, we lay a little bit less than 2 inches on average. So if you look at the square yard price for hot mix, it's $16.89 a square yard. So same amount of money, but it goes quite a bit further per square yard. But it's kind of the nature of the beast. I mean, we kind of talked about this a little bit as far as it's so hard to compare these, and so I think you have to look on a case-by-case basis when you do this. So anyway, we wanted to take a little bit different approach here, like Andy said, and we'll talk about that here now.
Just one comment we have, in our pavement design guide, we had this option for alternate bidding when you're actually doing concrete versus asphalt in projects, and most of you may be familiar with this chart here, kind of laying out the procedure for alternate bidding. So I just want to caution that is no longer a valid procedure. The feds have basically said they don't like that procedure and wanted us to come up with something different. So our alternate bid procedure is no longer valid. So if you're out there considering doing an alternate bid, you can't really go by this chart anymore. However, you still could use life cycle cost analysis to kind of weigh your options between asphalt versus concrete and see, which one is the better. Just caution with life cycle cost analysis, bad data in is going to give you bad data out. So you have to be careful with your inputs into your life cycle cost analysis. So next slide. All right, so what we wanted to do is try to talk about both payments in terms of sustainability. If you haven't heard the word sustainability or been around, it's coming. This is kind of just a cartoon of sustainability showing that it's here and it's going to tend to grow rapidly, and so be on the lookout. Sustainability is here, and so we wanted to try to talk about these pavement types in terms of sustainability.
So talking about exactly what sustainability is, and this is a diagram that we see a lot when we talk about that. And really, sustainable development is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And so it's really divided up into three sections. That's society, that's the environment, and the economy. And I think what you have to do is you got to get positive input from all those three variables have to work together, and if you can get those all working together, that's what really gives you true sustainability. And there's a lot of folks out there, and I know the feds talk about this, and we talk about this mandating things. And so, hey, this is a great idea, let's mandate it. And all of a sudden, if you mandate something, all of a sudden that tells me that probably the economics are not there, and they want you to force something. And so really that doesn't meet what we call true sustainability. And so when you look at this, you have to keep all three of these variables in mind. And so as we go through this, we'll talk about what sustainable development is and give you some examples looking at both types of pavements.
All right, one of the tools you have when you're talking about sustainability is this life cycle assessment analysis. Basically, it's looking at all aspects of a project from materials, construction, use, end of life, and then how you maintain that pavement or structure. And so we're going to kind of cover a few of these topics and just kind of see where does each pavement kind of give us a benefit, how can we use it, how can we maybe merge the two pavements together in some type of composite sustainability method. And so, but this is kind of the general framework of what you want to consider when you're talking about sustainability.
So talking about sustainable pavement activities, for if you look at project design considerations, things that when you go in and set up a project, there's a lot of things you have to consider, and some of these things include existing conditions. Am I building something brand new? Am I building something that I'm going to rehabilitate that's already there? I'm putting on top. You consider what your easels are. What's that life of that pavement going to look like? How much trucks I have? You know, there's goals that you go into saying, do I want congestion relief? What does the safety look like? There's some improvements that could be made there. You also look at phase construction. What's going to work better for the phasing and to keep traffic moving through the area? There's been a lot of projects set up for noise abatement. We got to address some of those issues, especially in our urban areas. And then reduction of emissions. That's a big thing in sustainability, and we'll talk a little bit about reducing emissions. And then whether you've got acceleration, deceleration, stop, start, turning traffic, things like that. Those are all considerations that you have to take into account, and there's lots of different ways to do that. Here's a couple of examples, and this picture here on the top left is actually in Virginia, and this is on Virginia 288, and it was a project I happened to be involved with years ago. But what it was the main lanes were dedicated concrete, and then there were some feeder lanes that ran alongside where there were hot mix. So it's just kind of a way to utilize both of these, what we call horizontal composite pavements. And then some of you recognize this at the bottom right, and we're saying sometimes you can dedicate truck lanes specifically and design those differently than you would the lanes for the traffic, because they're going to take so much more load. And so there's some opportunities there to do things a little bit differently. They don't have to all be designed the same way if you can separate the heavy load traffic like the trucks from the cars.
Another example is these situations where you have acceleration, deceleration, starting and stopping, intersections, border crossings. We have a lot of traffic just kind of sitting there and then starting and stopping, where you have to look at, okay, is concrete a better option in these locations versus asphalt? You know, you have our energy sector has a lot of these intersections where, you know, turning and starting and stopping, it's, you know, wreaking havoc on those intersections. So maybe we stop doing what's not working and try something new, and bring in concrete as an alternative to what we've been doing in those intersections. So that's just one example where we need to start looking at what we're doing now maybe isn't as sustainable as what we should be doing, and what other options do we have to make that intersection a little more sustainable. Here's another example of kind of a composite horizontal pavement where, and the intersection is concrete. The rest of the roads are asphalt, but leading into the intersection and the intersection itself is concrete, which is a little better suited for handling some of these turning motions, especially of heavy trucks and some of these oil rig traffic that's down in the different energy sectors. So we need to kind of consider these options as far as how we're building more, better, sustainable roadways.
This is a project, and this was actually in Phoenix, and most of the freeways in Phoenix are set up as concrete pavements, but as soon as they're set up, they're overlaid with PFC. They do it for noise, and this is one of these things where it's set up for noise abatement. The public there in Phoenix, this is what they enjoy this part of it, and they want it to be quiet. They like the longevity of the concrete, but they want the quietness of the PFC mix that goes on top of that. So they do this pretty much on all their freeways there in the city.
One of the sustainable aspects is the environment, and so looking at new technologies to incorporate to maybe help the environment a little. It's this idea of smog eating concrete. It's basically it's been used. There's coatings that you can apply on concrete surfaces that basically contain this smog eating material, and so using it in pavements, especially in areas where you have a lot of trucks just idling, checkpoints, border crossings, things like that, where as these trucks are just idling, that concrete will actually be basically decomposing the smog. And so looking at the environmental aspects of projects is another thing we need to probably start considering as well.
As far as material considerations for sustainable activities, there's a lot of different things we can do with materials, and one of the things we've been utilizing quite a bit and trying to utilize more is minimizing the use of virgin aggregates. Minimizing our natural resources, trying to conserve those, and like using RAS and RAP and recycled concrete aggregate. Those are things that we can all do to be more sustainable. That also reduces the transportation of materials, and we utilize some processes like in-place recycling and rubblization. We try to reduce the use of virgin asphalt as well in RAP and RAS, utilizing appropriate pavement preservation techniques and practices. In other words, applying that technique at the right time to make that roadway last a little bit longer. Improving cement plant efficiency and reducing emissions there at the plant. Improving HMA plant efficiency and reducing the emissions. And warm mix is one of those things we've been doing in the hot mix side of things. Reduce the cement content by using alternates like fly ash and slag. Recycle the white washout water at the concrete plant. Using SCMs in concrete to improve durability. Using marginal materials strategically. And Andy will talk about this a little bit, this 2-lift concrete pavement in just a moment.
These are just a few examples of kind of what Robert was touching on as far as the use of recycled materials. Again, RAP and RAS are already heavily used in asphalt concrete pavement. Now we're looking at maybe potentially allowing that in concrete pavement, see if there's any benefit to using RAP in concrete pavement. Recycled crushed aggregate, Houston district has, and I think several other districts have used quite a bit of recycled crushed aggregate in their concrete pavements. It can be done. There are some considerations you need to be aware of, but it's very well suited to be used as recycled material. Again, RAS, I think we have a presentation later on this afternoon about RAS. And then all these SCMs, fly ash, slag, metakaolin, all these materials that are considered a waste product, we need to really start streamlining those things back into our structures and pavements.
This is warm mix, and a couple pictures here of some projects where they've comparing the hot mix product to warm mix, and just by putting the additive in there and lowering those temperatures, we're able to reduce emissions there around the paver. And that's not steam coming off there; that's actually fumes and emissions. So it's definitely healthier for the guys around the paver. But it's also reducing the emissions that we're emitting. So both of those, this activity is very sustainable. We continue to utilize warm mix in all of our pavements. And we talked a little bit about reducing transportation of materials, and we've utilized this hot in place. You'll see that's the one on the bottom there with the long train of materials. And then rubblization. Instead of coming in and taking out that pavement and then bringing back something new, you're actually just keeping it in place, reducing the transportation costs, reducing the materials hauled back and forth. So still very sustainable, and just need to continue to look at that and utilize these type of products.
Illinois Tollway Authority has a mandate that nothing leaves the right-of-way. So if it was in the right-of-way, it has to be used in some form or fashion. So they've taken a big step of basically trying to do 100% recycling of their existing pavement. So I think that's a kind of a model that maybe a lot of other DOTs need to probably look at. Robert did mention this two-lift pavement. This is kind of it's not a new concept. Probably one of the first pavements ever built was a two-lift pavement. But the idea here is that lower lift of concrete pavement can have a high amount of recyclable material or materials that you would not really want near your surface. High limestone fine concrete mixes, you don't want those for polishing issues, and so you would put all that material in the bottom lift, come back with a second lift, right, it's a wet on wet, and design that mix for your certain property. Maybe you want texture, maybe you want noise reduction, so to use that top surface as a higher quality concrete. And so we're looking at trying to build one of these in the Houston district, hopefully coming up really soon to help with their issue of utilization of local aggregates, high coat materials. We really don't want those near the surface of concrete pavement, especially CRCP. However, if we put them in the bottom lift, well, that saves the contractor a lot of transportation costs of bringing in those materials where he would normally have to haul in limestone from San Antonio or Houston. Or from Fort Worth district. So this seems to be a pretty good option to try to use a little more locally available materials. Some other considerations as far as on the design and rehab alternatives. Again, looking at asphalt pavements, are you going to build new asphalts? Looking at these perpetual pavements, are these longer lasting asphalt pavements? Some structural overlays, and then when that pavement comes to the end of its life, can we put a bonded or unbonded concrete overlay on top of that? Again, these are just some options that we need to probably consider when that asphalt pavement reaches its end of life. On the other side, concrete pavements, are we going to build a lot of new CRCPs? We are looking at allowing the use of jointed concrete pavements a little bit more in TxDOT. We've kind of loosened up our allowances on where and when we can build jointed concrete pavements. And then when those kind of reach its end of life, look at bonded and unbonded overlays, and then structural overlays of asphalt. Robert mentioned the one where you could rubbleize the concrete pavement and come back with a structural asphalt layer. So these are just options that we kind of need to consider as we're moving along. And then this idea of kind of these other newer techniques, looking at composite pavements, drainable pavements, and then modular pavements.
And this is really what Andy referred to as our perpetual pavement. It's trying to build basically a longer lasting asphalt pavement. And we've done several of these in the state. I think the opportunity there is just not there. We're kind of in that rehab mode and the overlay mode, and we keep getting thinner when maybe sometimes we need to think about getting thicker when you look at life cycle cost and over a longer period of time and having to have less rehabilitative work on these asphalt pavements. So, and that's the same, I think, with your discussion where we talked about, Andy, with concrete, is that you've got a certain thickness that you hold, but it's got a certain life expectancy that goes with that. But then all of a sudden, is there something you can do to create a thinner concrete overlay, right?
Yeah,
don't let me put words in your mouth, Andy.
Kind of along the lines of what Robert was saying, this is some data from LTPP sites in Texas showing basically the life of those concrete sections. As you can see, the black bars are sections that they've already seen their end of life. They've had an overlay or something done to them. However, the majority of them are still going, and a lot of them are already at their 30-year service life, and there's really no indication that they're failing. They're performing excellently, and so I guarantee most, if not all, of these pavements have seen their 30-year traffic life, even well before they were 30 years old. So that kind of brings in the question, are we building our concrete pavements too thick? No one's ever kind of got mad about, hey, a concrete pavement lasting 40, 50, 60 years, we built it and it's sustained that much traffic, and which is great. However, if we build thinner concrete pavements that only last 30 years, is that a more sustainable activity than building thick concrete pavements that will last 50, 60 years? And so I think we need to start bringing this into discussion of what is our concrete pavement thickness, and is what we're currently doing the right thing to do, or should we actually start trying to thin up concrete pavements and only have them last 20, 30 years? You know, asphalt, their surface life is 10, 15, 20 years. Throw a number, and I guess whatever target you hit. But and so, why is it acceptable for asphalt pavements to only last 5 to 10 years, but we're building concrete pavements that last 50, 60 years? And it's always been the thing we hang our hat on with concrete pavement is it's going to last you a really long time. But is that the thing we need to really do? And that's and I'm not saying all you concrete pavement guys just take a sigh, take a breathe, and we're not actually going to do that. But we need to start having these discussions of what is direction we want to go with concrete pavement. If we're ever going to be competitive with asphalt, you know, that's one of the things we're going to need to consider. So this is a thing for discussion, so just keep that in the back of your mind of what do we want to do moving forward with concrete pavements. One option that we have been using a few times, and we've actually got some pretty good success, is white topping. You know, and these are on intersections where there have a lot of heavy truck traffic where the asphalt pavement was just rutting. And they come back in and redo it with asphalt and rut it again. So we ended up doing white topping. And we've had several of these come down, put down, and they've been down for a number of years, and they've been performing really well. So again, this is an option that we have, is thinking about one of these kind of composite pavements of putting a concrete layer on top of asphalt that's giving you problems. And so that's just a really good option that we have. Again, we've gotten 10 to 15 years out of some of these white toppings, so they do last.
And they are thinner?
Yeah, we're right around about 5 inches. What we recommend is to be the thinnest white topping. So.
And I guess going back to what you said, you know, when you've got these long-lasting concrete pavements, but sometimes they lose their frictional properties on the surface. So one of the options that we've utilized here for safety reasons, and it gives you a lot of other benefits, is putting PFC on top of that as a riding surface. So you can see the difference here between the side that's been just paved, and then the one that's still the old concrete surface. So I mean, it's definitely an option to come in here and put these new PFC surfaces on here, and it extends the life of the pavement as a whole, I think.
One kind of, not a new technology, but it's kind of being used a lot more, is the idea of precast concrete pavements, where you actually build your slabs off-site at a precast yard and truck the slabs in and then set them down. And then you basically have your concrete pavement ready to go. This kind of helps speed of construction. You're not hauling in materials from all over the place to a ready-mix plant that's kind of nearby. Your slabs are already done, and so you just bring them in, set them down, and you're ready to go. There's several different methods of it, whether you do pre-stressed post-tensioning slabs or you just do kind of jointed pavements. We're doing one in San Antonio, State Highway 97 and 72, the intersection there. Again, it's one of these energy sector intersections where a lot of stopping and starting, turning motion, that's, you know, it's really tearing up the asphalt. So we're coming in and doing a precast concrete slab pavement to help alleviate, and hopefully that will be a step to do a lot more of these concrete pavements in these regions where some of the asphalts that you basically have flex base and the seal coat on it just aren't holding up to these traffic conditions. So this is a little more expensive, but it is definitely going to be a longer lasting structure.
This is one of a new concept, and I saw the patent out on this, and there's a few test sections that are being implemented right now. But what this is in basic is, they call it ultra high strength asphalt. It's basically, you take it's like a PFC mix that's got a lot of void structure, and you put a cement binder in the void structure. So it's like full composite. It's both of the materials together. I thought that's a very interesting idea. Of course, I haven't seen any test results or any long-term performance, but other than the fact that they're doing some test sections with it now, and anyway, it just takes that whole composite to another level. This is one of the things that I know they're doing a lot over in Asia, is when they build their bridges, they build them with steel decks. and actually they've been going in and putting hot mix on top of that steel deck with an epoxy. And so it takes a special product to do that, but it's just these different ideas, different ways of looking at things. You've got certain projects that are trying to utilize that, and this is another way that they're trying to utilize the hot mix, but it's over the steel bridge deck.
Roller compacted concrete is another kind of, it's not a new innovation. It's been around since probably the 70s. It came from the logging industry due to them tearing up the roads near their mills. TxDOT is actually doing the first RCC project in a rest area in Eastland. From what I understand, it's actually going quite well. They just started paving a few days ago. But again, it's a dense concrete mix. You place it with a high density paver, roll on it, and then you get traffic on it within 3 days. We're looking at different options. Maybe we get traffic on sooner. Maybe you do a chip seal over that surface that same day, maybe able to get traffic on. So we're trying to look at different things to do to help out some of these energy sector regions where either hot mix isn't holding up and we want to get something a little more rigid down there to help those areas out.
And you can overlay it with hot mix too, right?
Yeah, I mean, we could definitely do that as well. Yeah, I did. Okay, some other considerations on construction. Again, these are kind of more things contractor driven as far as equipment and fuel efficiency and idling times and things like that. But again, it's bringing back this environmental aspect of sustainability and when you're building pavements. On the asphalt side, again, just construction quality, right? Hitting your target densities and joint construction, those things are key to making sure that pavement will last more than 2 years. Hopefully it gets done.
Man, I felt that one.
On the concrete side of things, again, ride and noise are probably the two biggest things for concrete pavement. It's always an issue of like we can't get good ride on concrete pavement and it's noisy. And so those are really the two aspects that I really want to focus on in the next coming years of how do we get better riding concrete pavements and quieter concrete pavements. So we're working on a few things to hopefully help with that.
Just wanted to bring this up. When we talk about sustainability, and there's a lot of things, most of the time that these ideas kind of come through industry. And so industry promoted this idea. When they built the Cowboy Stadium, they wanted to do a very sustainable project overall, and that included even the parking lot. So this was actually the first project that used RAP, RAS, and warm mix technologies together. And going through the calculations, it's a 23% reduction in emissions. So how much? You were looking at me like time. Are we good with time? We're out of time? Man. All right, there's accelerated construction, notch wedge joint. These are all good practices. PAVR system. We are utilizing the PAVR. We love this. It's a great tool to help us. And I'll let you talk about this.
All right, for ride quality and smoothness, there's a lot of things we do. Existing pavement, diamond grinding. Next generation kind of concrete surface is kind of gaining some speed. Things you can do with fresh concrete. This is kind of some new specifications looking at optimized graded aggregate. Really does wonders for ride. Other DOTs who've gone this way have reported rides in the 40s and 30s, so unbelievably low ride scores. So we're actually moving that direction in our new concrete specification. These are just some maintenance preservation activities for each type of pavement. I'm not going to really cover. We kind of talked about some of these already, so we'll just move on. We're out of time. So.
Yeah.
All right, just kind of wrap it up. Again, we talked about the alternative bid process is no longer valid right now. And then when we're talking about sustainability of pavement selection, again, these are the considerations you got to kind of keep in mind. And with that, I guess we'll just end it. Any questions?